With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. What the question says, the packing efficiency of a simple cubic crystal with an interstitial atom exactly fitting at the body center is. We have to find the packing efficiency of a simple cubic crystal and in which an interstitial atom exactly fits at the body center. Now we know that this is the 2D structure of simple cubic crystals. All the atoms touch each other. Now firstly we will get to know the relation between the radius and the edge length, that is A, and suppose the radius is R. Now from here we can get that 2R, twice of the radius, will be equal to the edge length, that is A. Now this is the initial case. Now what happens, one atom fits here in the body center of this simple cubic crystal. Now it will be like this. If we study the body diagonal of the cube, it will be like this. This is the one atom that is associated with the body center, and this is the line representing the body diagonal of the cubic unit cell. Now we know that length of the body diagonal of the cubic unit cell is √3 times the side, that is √3 into A. From here we will calculate the value of radius of this interstitial atom. We are given with the radius of this atom and radius of this atom, and these all atoms touch each other. Now we can see that √3 times A, that is the length of body diagonal, will be equal to R, that is the radius of this atom, plus twice the radius of this. Let us suppose the radius is X, so it will be twice the radius of X plus R. Now from here we will get the value as √3 times A will be equal to 2 into X plus R. Now we know that A is equals to 2R. We will fill down the values, that is √3 into 2R will be equal to 2X plus 2R. Now this will be equal to 0.732 R will be equal to X. This is the relation between the radius of interstitial atom and the radius of the simple cubic crystal. Now we have to find the packing efficiency of this. Packing fraction or the packing efficiency is the volume occupied by the atoms, volume occupied by the atoms, total atoms, divided by the volume occupied by the cube, that is the volume of cube. Now we know that if we calculate number of atoms per unit cell of simple cubic crystal, they are equal to 8 atoms are associated with the corners and their contribution is 1/8, so there are total 1 atom per unit cell. So the volume of one atom will be equal to 4/3 pi r cube, that is the volume of sphere, 4/3 pi r cube. Now one more atom is added, that is the interstitial atom. The volume of interstitial atom will be added, that is 4/3 pi x cube. X is the radius of that interstitial atom, divided by the volume of cube, that is the cube of side. Now from here we will get 4/3 pi common, and we will fill down the values of X, that is 0.732. It will be 0.732 R cube, and we will fill down the value of A, that is 2R, so it will be 2R cube. From here we will get, after solving, the packing fraction as 0.732. So this will be the packing fraction of this crystal system. So the answer will be option number C. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.